Hello everyone and welcome to IT Product Connections. My name is Kostas Stroggylos and today I'll be talking to you about Carter, a lightweight web framework built on top of ASP.NET Core. First, a few things about me. Let me share my screen. All right. So, I'm a senior software engineer at E4GR that belongs to Delivery Hero. I'm also consulting and providing advice at Upwork. And I'm also the organizer for the Domain-Driven Design Greece meetup. I have been involved with .NET since version 1 more than 15 years ago, and I'll be happy to share my knowledge with you today. So without further ado, let's see what's on the agenda for today. First of all, I'll be talking about the history of Carter and how it came to be. Then we'll see how we can set up a project to use Carter. We'll see how we can handle requests from our API, from our service, how we can use model binding and validation, and we'll move on to OpenAPI support like Swagger, as you may know it. And then we'll see a couple of more advanced topics like content negotiation and error status handling. So first, for a bit of history. Perhaps a lot of you have heard of Nancy, this lightweight web framework that was very popular from 2010 to 2017. It was built on top of Owin, and it was perhaps the only actual contender for ASP.NET at the moment. Since it was portable, it could run on Linux, on Mono, or any kind of platform, on IIS, or even as a self-hosted application. And it really had a vibrant community. However, this project stopped being maintained a couple of years ago, and a few months ago the plug was officially pulled and it's now archived. But I guess there are a lot of projects out there still using Nancy. And what we'll be discussing today is Carter, which is kind of a replacement for Nancy. It was built by one of the core contributors to Nancy, and it kind of provides most of the same functionality, but is now built on top of ASP.NET Core. There's no reason to base it on top of Owin, since we want to take advantage of all the improvements in performance and all the goodies that ASP.NET Core has to offer. So let's see, what is Carter? Carter is a lightweight framework that provides a thin layer of extension methods and some functionality on top of ASP.NET Core. The most basic characteristic is that it maintains the Sinatra-style routing that used to be also used in Nancy. So this is the most, let's say, defining characteristic. It provides model binding and easy validation using the Fluent validation library, and can provide some custom or more advanced, let's say, things like response contact negotiation and alternatives for middleware like usage code pages that we have in ASP.NET Core. So I don't want to book it down with a lot of slides. I'd prefer to move on to the demo. So you can also ask any questions if you like at any time, and I'll keep my eye on any questions and try to answer them during the talk. So I have set up a simple empty ASP.NET web application, and I have added a couple of dependencies that we will be needing today. The first is Carter, which is the only library that we need in order to use this framework, and the Swashbuckle ASP.NET Core library that is used for OpenAPI support. As you can see, I haven't changed anything yet. My startup class is the default, and so is my program CS, just the default web host builder. And actually using counter is just adding a couple of lines of code. In order not to lose time with writing code, I have prepared some code already, so I'll be updating it as we go along. Okay, so the only two things I need to do in order to use Carter is in configure services, we need to add it to the service collection, and then in the use endpoints in configure method, we just need to map Carter to the endpoints used by our application. So actually, all the methods that are provided by Carter are extensions to the iEndpoint route builder, which means we can use standard, let's say, methods like requiring authentication or things like that that we use with typical ASP.NET Core controllers. So in order to be able to use Carter, we now need to write a module. A module is quite similar to what we call a controller in ASP.NET Core. It's just a class that is subclassed by Carter module, and it provides a DSL, a domain-specific language, that allows us to define our routes and handle the requests to these routes. So you'll see I have set up a couple of requests here. What we need to do is in our constructor, we have some specific methods that each correspond to an HTTP verb. So if I write a get handler, I have a request handler that handles get requests. And this method takes as a parameter the HTTP request and HTTP response and can evaluate the contents of the request and handle it and provide a response to the client. So this is just all we need to write in order to write a simple text to our HTTP response. Let's see how this works in action. I have set up a Postman collection here with some basic requests. I will start the project now. Let's give it a sec to build. Almost there. It's the first build I'm doing today, so it takes a bit longer. Okay, I think we're ready to go. And if I fire up Postman, this is the simplest request I have done. So you see that this handler handles all requests to /API/hello, and it just write a simple text to the response. So let's try it out. And we're good. This is our response. So that's all there is to it, writing a simple GET request handler. Now, the nice thing with Carter is that it follows all the root conventions we have for defining root segment constraints and things like that. So, for example, I have set up a more complex route here that has a couple of URL segment parameters, and I have set up constraints for these two numbers. This is just a simple endpoint that would provide the sum of two numbers, which I provide as URL segment parameters, as root values. We have here just a little code to retrieve these values, and then just write the response to the string. So let's see how this works as well. So I have added the two parameters in my URL as URL segments, and I'll be sending the request and see what comes as a result. So there we are, this is the result, and we're good to go. Now, besides GET requests, we can handle any kind of HTTP request like post or delete, or all the HTTP verbs are supported. So I have set up a simple example with a post request here that grabs a couple of parameters from the request body as 4 parameters and just again returns their sum. So it's right here. I have set up this URL, and in the body I'm sending a couple of parameters, and let's see how this works. So again, we get the expected result. So as you can see, the syntax is very, very simple. It's just a matter of implementing a few handlers for our routes. So it's very easy to define the routes. You don't need to use the conventions used by ASP.NET or controllers or attribute routing or things like that. And in my opinion, it makes it a lot easier to read the kind of routes that each handler is taking care of. Okay, so that's it for the first step. Now, one more thing I'd like to discuss here is you'll see that you have, in this case, you don't need to implement all the code for handling a request within the same this function. You can either use some kind of, you can either write a specific action handlers in your class or in some other class and just forward the request there. So you don't need to create this huge, let's say, controller-like thing. It's easy to write modular code, and it's easy to break your API surface into smaller modules based on the kind of functionality you provide. Okay, let's move to the next step. So let's see how we can move on from simple requests to things like model binding and validation and things like that. In order to do this, let's suppose we're building a simple API for handling to-do items. So what I have done is I have built a model for a to-do item, just a simple classic plain old C# object with an ID, a category, and a description. So these will be the items that our API is handling. Then I have set up a simple interface for an item provider that provides all the basic methods like get, add, delete, etc. So I'm not going to use a full-fledged repository and DB context and things like that. Just an in-memory store with a bagging list for some to-do items that provide all this functionality for demo purposes. And I am setting up a few items from the get-go. Like we have 3 items. One is for shopping, another for course, another for work. So we can see how all this thing works. And I have also configured my startup class to register this provider, let's say, services collection, so that I can use dependency injection. So in this sense, a Carter module is very similar to a controller because you can use the dependency injection mechanism provided by ASP.NET Core and just inject any kind of thing you need, any kind of service you need in your system in order to be able to use it from your modules. So I've created another module that will be handling our to-do items. This is also a subclass of Carter module. But this time, since I want to avoid writing all the full path of the API request that we will be handling, I'm calling the base class constructor and providing the base path. So each request handler that is declared in this module will live below /API/to-do. So all the other endpoint handlers will be handling requests relative to this path. Okay, so I have a GET request for the API/to-do/, which would return all the items available in my provider, in my collection, let's say in my repository. And you can see I have this method here that allows me to return these items in JSON format. I will talk later about content negotiation, but let's see how this works. We can see how simple it is to provide such a simple API. So I'll fire up the project again. Hopefully it will not take so much time to build this time. As you can see, the syntax is very simple. We just write something into the response stream, and we format this collection of items as a JSON in JSON format. So we're ready to go. And there we are. So this is my GET request to retrieve the items as JSON, all the list of items are already in my repository. Of course, I could provide any extra URL parameters or things like that, but we'll see that later. So as you can see, the response we get is the list of items we have in our repository in JSON format, and this is just a simple example. But let's move on to seeing how we could, for example, return a specific item from our list. So in this request, I have a parameter for the ID of the item we need to retrieve. Again, we request it from our provider, and if we don't find it, we just return a not found result. So setting up the response status code is as simple as that. Otherwise, I'm using this method here that says renegotiate, which enables the content negotiation I was talking about earlier. We'll see what this means in practice later on, but for now, just keep in mind that by default, any kind of model or view model we need to return as a result is serialized using the default JSON serializer, so system text JSON in .NET Core 3.1 and onwards. But we can override it by writing our custom response negotiators and writers. We'll see about that later. So let's see how this example works as well. In this case, I'm just passing in the ID of the element I need to retrieve as a URL segment. And there we have our item, again in JSON format. All right, so we have another method that would allow us to retrieve items by category. So in this case, this category element is a string that we need to provide to our repository to filter out items. Again, just for demo purposes, let's see this. So for example, in this case, I would retrieve all the items under the work category. So you can see it's pretty flexible, and we can provide any kind of parameters or the typical all the constraints, all the root value constraints we set up for that are supported by ASP.NET Core are available in Carter as well. Just for the sake of demo, in this case where we had let's say we pass in an ID of an element that doesn't exist, you will see that we get the not found result and the 404 status code as we have set it up here. in this line. All right. So this is I guess it's a pretty fairly standard. It's just to get us acquainted with the syntax for setting up root handlers. Now let's move on to something more interesting. Like let's see how we can bind some models for our request from our requests and do some validation. Okay, so I will start the project now and bring in some more code. All right. So I have created a simple validator for our to-do item using Fluent Validation, which is a pretty standard validation library for .NET. So this validator just checks whether our to-do item category and description are not empty. We could set up a number of rules here that are quite complex, but this will do for now. So one of the things that is, let's say, important in Carter that we need to keep in mind, and it's the same philosophy as we had in Nancy, is that it's better to have specific, let's say, models for our requests and our responses to make sure that handling them is consistent, that we use the type safety and all the nice things that the type system provides to avoid things like overposting or things like that. In this case, I won't be doing that. I will only be using the same model for the requests and the responses, but you can define specific models for requests and responses, which would make the code safer and cleaner to read. Anyway, so I have set up a couple of examples for handling the binding and validation of these items. So I have created a post method that would be used to add a new item to our collection of to-do items. This extension method is provided by Carter and allows us to bind the request to a specific type of model, in this case the to-do item, and do a validation on it. There is also a simpler override, which would be like var to-do item equals await. It's all asynchronous. Request dot bind to-do item. So this would do just the binding part, not the validation. The bind and validate overload just also provides a validation result using Fluent Validation. If we try to do a simple binding and it fails, we will get a default value for the to-do item. So in this case, it would be a null object. But if we want to do validation, which is always a good practice, so we can use the other overload and do all the validation in one step. So what we get from this bind and validate method is just a validation result and to-do item tuple. So we can check whether the validation result is valid. If not, we can send a response with the validation result errors. Otherwise, we will proceed to adding the item to our repository. If something goes wrong, we will return code that indicates that something when process the request. Otherwise, we'll send the status code indicating that the item was created and we'll get the newly created item back. I will start the demo here now. So you can see it's pretty straightforward. I mean, just validating our input and then based on the result of the validation, deciding whether to proceed or not. One thing to keep in mind here is that any kind of exception occurs here and we don't handle it, we will get a 500 error back. And we will see how we can format errors later on. Okay, so let's start the Postman again. So here I will be posting a new item. You can see that I'm sending a post request to this URL, and as a body I have set up a JSON body containing all the fields that I need for the new item. So I'm setting up a new work item with a description of write code, and when I send it to our service, the new item is created, it is added to our repository, let's say, and we get back a 201 created HTTP status response. If I had omitted, let's say, the category, then my validation would fail and I would get back a set of errors. I get back a bad request response, and we have a list of uh, validation errors. So we have an error that says that our property named category cannot be empty. So this is just an easy way to format our responses in the case of validation errors. Okay. Please interrupt me if you have any questions at any point in time. I'll be happy to answer them. If not, I will proceed to the next example. So here we have another example where we update an existing item. So we're using the put verb so that we'll be good, let's say, we're using the proper REST HTTP verbs. In this case, I am just, binding the item again and then checking if the validation result is correct. In this case, I have used deconstructing of this tuple to get the validation result and item in one step. So my code is a bit simpler. Then I bind the ID from the request and then try to update the item. So if everything works as expected, I just update the entity and provide the OK status code. Otherwise, I just return an error status code. So let's try to run this as well. Suppose we want to update the item we just created previously. So I will be updating the description for the item with ID of 3. And you'll see that we have updated the item, and we get back a status 200 OK, and we return to our user, to our client, the updated entity, the updated to-do item. If I had, for example, omitted the description here, again, I would get back a bad request response. So we get a bad request and an error saying that the description cannot be empty. All right, so this is pretty basic. Let's see how the delete would work as well. I have set up here a handler for deleting an item from the repository. Again, we're binding to the value, to the identity of the item we wish to delete. If we don't find it, we return a not found status code. If we delete it, we return a no content response. So as you can see, you have actually two options. You can either write async code in this handler and return, for example, an item, like for example here I'm negotiating on the result, or you can write a non-async function that needs to return a task when it's complete. So in this case, what I'm doing is, since I don't have any asynchronous code to run in this handler, I'm just doing this processing and then returning a complete task to mark the handling of the method as complete. So let's see how this works as well. There we go. I'm going to delete item number 3. So it was successful and we got back a 204 no content response. If I try to delete a non-existent item, I'm going to get back a not found response. Or it could return like a bad request response or something like that. Okay, so these are the basic examples with binding and validation. You can see it's pretty basic. It's not really so much different compared to what we usually do in vanilla ASP.NET Core. But let's see how we can use some other features that are very interesting. So I'll be stopping the project and bringing in some more code. So, as you know, ASP.NET Core uses a kind of pipeline mechanism where you can set up various middleware to process the request and possibly post-process the response from our handlers. Nancy used to have an implementation of such a mechanism based on Owin, but since since Kata now uses the ASP.NET Core pipeline, we just have a couple of extension points that allow us to do some more, let's say, advanced stuff without needing to write middleware. So we call these hooks. So each module gets a before hook and then after hook. And you can, it's just a couple of methods you need to define besides any other root handlers. So I have set up a hooks module here that will be handling requests to /API/hooks and routes below that. And what I'm doing here is I have a before handler, a before hook, let's say, that receives as an argument the HTTP context of the request that is about to be handled, and might do some checks or whatever, or any interaction with the request. So what I'm doing here is I'm checking whether our request contains a specific header. If not, I'm setting the status code to be forbidden and giving a descriptive error message and returning false. Otherwise, I return true. So this method actually receives the HTTP context as a parameter and returns true or false based on whether the processing of the result of the request should continue or not. So if we return a false here, we're just short-circuiting the request processing and returning a specific value or whatever. If this method is called for all requests that are handled by this module. So, for example, I have set up a method here to handle a GET request for the /API/hooks route. And what I'm just doing is writing a specific text here. So, for example, let's see how this would work in practice. I'm going to start this project. Okay. And what I'm going to do is I'm going to send a request to this route without any specific headers. So this is the URL I'm going to hit once the project is ready to run. Okay, I guess it's running. Let's see. No, I guess it's not started yet. Let's try again. There we are. So we got back a forbidden result and required header missing value, which is what we had set up in our before hook over here. Over here. So this means that our request handler was never called at all. It short-circuited the processing of the request and we never got here. So for the next example, let's pass on this this header. I have set up another request that sets this header with a custom value. And when I send in this request, you'll see that we get a response that says got here and ended up here. Now, where does this ended up here come from? What I have done is I have set up an after hook, which allows me to process the request once it's been handled, the response, sorry. So what happens is that I process the request using this request handler, but then we have another method, another hook that is called after the processing is complete, which allows us to modify the response. So I could set up a different status code or by examining the response that is generated, or I could perhaps do some kind of formatting or whatever. So this is a very nice mechanism that is very simple. We apply it on a module level, and we don't need to write specific middleware for this process that would need to examine any kind of other factors before enabling it to process any requests. Now, since any good API needs to be documented, we'll see how we can also provide Swagger documentation from our API. So since we don't have a lot of time left, I will move quickly to the next example. So as I mentioned in the beginning of this presentation, we have included the Swashbuckle AppNet Core library so that we're able to generate an open API UI and things like that. So what I'm doing is I need to modify some options during the configure services here when I'm setting up Carter. I need to pass in these options, this Carter options object, and then modify set up the document title for the Open API document and the server URLs that will be used to host this Open API UI and definition, let's say. And also here we need to, and we're going to use this Swagger UI, set it up for /OpenAPI UI, and set this Swagger endpoint to be /OpenAPI. So this is a URL where we can retrieve the definition, the Swagger definition for our API description, and then here we can access the OpenAPI UI, which allows us to actually try out the various routes we have set up in our system. Now, the thing is, we somehow need to provide some kind of documentation, some kind of description on what kind of responses or what kind of parameters its endpoint requires. So let's see how I can do this with Carter. I have set up a new folder here called API, and I have written a couple of classes here that are subclasses of root metadata. So this class is, let's say, a metadata class that provides all the information required for describing what happens when we try to get the list of to-do items. By overriding various properties like the description and tag and things like that, we can describe the action that is performed with this endpoint. And then we get a set of responses here that describe the kind of result that is returned in each case. So in our case, we have, for a successful request, a code of 200, which is HTTP OK, the description, and the response type. This allows the Open API to provide a description of the kind of response that our client will receive. I have also set up a similar class here for the get to do item by ID, in which case I have set up a couple of responses. One is for a successful response where we return a type of to do item, and one for a 404 response if the item is not found. So I have also added a new metadata description for and the action that is run when we post a new item, when we create a new item. So in this case, you'll see we have also a description for the request that this endpoint is accepting. So this endpoint accepts a to-do item request, and can provide all these types of responses based on the outcome of the processing. But how do we wire this up with the specific endpoints that will be handling these requests? Well, there is a generic overload. Let's go back to our to-do module. So there is a generic overload of these methods, the get and post and things like that, that allow us to define the kind of class that provides this metadata for each route. So for the get to do items, for the get method that provides the list of to do items, I have let's say it's similar to an annotation. I just use the type of metadata class to use for this route, and similarly for the post. Let's see how this works in practice. And I'm afraid I might not be able to show all the things I had in mind for today. I might be able to show one more thing, and we can call it a day. So once it's up and running, this is the endpoint where we have set up our startup class to provide the OpenAPI Swagger definition. So if I send a GET request here, I will get back the Swagger document describing the requests and responses that my API provides. So there it is. And we can also use the OpenAPI UI to see the UI that allows us to interact with our service. So you can see that we have set up the metadata for these three requests. So for example, when posting a new item, this is the kind of request body we need to send and the kind of responses we will get if the item is created successfully or the request validation phase or the item could not be created. So it's an easy way to provide this documentation, this metadata, without really messing up our code too much and needing to add any comments or any other kind of annotations for our root handlers. Okay, so as the last demo, I'd like to show one more thing. We won't be able to move on to the content negotiation and things like that, but never mind. We can continue the discussion offline, or I will upload this sample on GitHub so you can take a look at it. So one thing I'd like to mention here that is quite useful is that you can actually use Carter along with default controllers, standard ASP.NET Core controllers. So what I would need to do in this case is I would need to go to my startup class and enable the use of controllers by adding controllers in the services collection. And then in the use endpoints in my configure method, I would map the default controller out that allows me to use the convention-based routing for ASP.NET Core controllers. And then I can just add a new controller to my project and do the usual dependency injection and things like that, and just handle this request. So this is similar to the to-do module here that just returns the list of items from my repository from my provider. So you can see it's really quite similar. So it's a nice way if you need to migrate a project from Nancy to vanilla ASP.NET Core or things like that. You can have classic controllers and Carter modules living in the same project at the same time. So so this is the URL I would need to hit in order to access this this action handler. and it works the same way as we expect, supposing the service has started. So I guess we're out of time. Um, just one more last attempt. So I'll stop my screen sharing. Just it hasn't started yet. Anyway, um, I would stop sharing my screen now and see if there are any questions. Um, no questions here from what I can see. I don't know if somebody would like to open their microphone and ask something on the things I have showed you today. If not, I guess we can stop this session now. Okay, I guess there are no questions. I'll be happy to continue this discussion later on offline or on. You can find me on social media or whatever. So this is where you can find more info about Carter. Let me. This is the URL for Carter. You can find more samples there, and you can find me on Twitter, on LinkedIn, or whatever. We can connect there and keep the discussion going. Thank you for joining today, and have a great conference.